Welcome to Spaceverse, your portal to cosmic adventures. We are getting closer to unlocking the secrets of how stars and planets formed in the harsh conditions of the early universe. At this point, astronomers are used to the James Webb Space Telescope pushing the boundaries of what we know about the cosmos. But even by JWST's own incredible standards, its latest findings are nothing short of extraordinary. In collaboration with the Hubble Space Telescope, the James Webb Space Telescope may have just spotted a population of so-called failed stars, brown dwarfs, in a location where no one has ever seen them before, outside our galaxy. That's right, for the first time in astronomical history, scientists may have detected extragalactic brown dwarfs. And it all happened in a satellite galaxy of the Milky Way known as the Small Magellanic Cloud, or SMC, a cosmic neighbor roughly 200,000 light-years from Earth. This discovery doesn't just mark a first in galactic exploration. It also provides crucial insights into how stars and planets might have formed in the metal-poor, turbulent conditions of the early universe. Let's break this down. The potential brown dwarfs are located at the very edge of the SMC, in a particularly intriguing young star cluster known as NGC 602. This region has long fascinated astronomers. Why? Because it's full of the essential ingredients for star formation: dense clouds of gas and dust, thick enough to block most visible light. But those same dusty clouds that make it an exciting site for stellar birth also pose a significant problem. They absorb visible light, which makes it incredibly difficult for traditional telescopes to peer inside. Enter the JWST. Its near-infrared camera and mid-infrared instrument observe in long-wavelength infrared light, the kind that can slip through dust clouds without being absorbed. These instruments are tailor-made for cutting through cosmic fog and revealing what's hidden inside. So when JWST turned its sensitive infrared eyes toward NGC 602, the results were predictably amazing. JWST, as part of its General Observer Program number 2662, revealed what appears to be a population of brown dwarfs, celestial bodies that form like stars but never quite make it. Now, before we dive into what this means, let's talk about what brown dwarfs are. Brown dwarfs are often nicknamed failed stars. It's a term that sounds a bit insulting, but it's actually quite accurate. Like stars, brown dwarfs form from a collapsing cloud of gas and dust. The gravitational pull squeezes this cloud into a ball, heating it as it contracts. But unlike regular stars, brown dwarfs don't accumulate enough mass to trigger the nuclear fusion of hydrogen into helium in their cores, the very process that powers our sun and defines main sequence stars. To trigger hydrogen fusion, an object must be at least about 75 times the mass of Jupiter, or roughly 0.075 times the mass of the Sun. Brown dwarfs typically fall short of that, coming in at 13 to 75 Jupiter masses. That puts them somewhere between the largest planets and the smallest stars. Because of this, brown dwarfs glow faintly in infrared but never achieve the blazing brightness of true stars. And unlike most planets, they aren't necessarily bound to a parent star. Many wander through space on their own, rogue and isolated. What's fascinating is that they often share atmospheric features with gas giants like Jupiter and Saturn, including powerful storms and complex cloud structures. In a way, brown dwarfs are cosmic hybrids, part planet, part star, but ultimately their own strange category. Up to this point, astronomers have detected roughly 3,000 brown dwarfs, but every single one has been located within the Milky Way, which is what makes this new discovery so exciting. If confirmed, the objects spotted in NGC 602 represent the first ever detection of brown dwarfs outside of our galaxy. It's a monumental step forward, and it's not just about spotting a few distant objects. It's about understanding how stars, and by extension planets, come into being in extreme environments. You see, the Small Magellanic Cloud, and especially regions like NGC 602, are metal poor. That's astronomer speak for having a very low concentration of elements heavier than hydrogen and helium, elements that we on Earth and most of the planets and stars we know are largely made of. In the early universe, shortly after the Big Bang, only hydrogen and helium were abundant. Heavier elements, or metals, formed much later inside stars and were scattered across galaxies by supernova explosions. So when astronomers find places that are metal-poor, they treat them as time capsules, as analogs for the conditions of the early universe. According to University of Arizona scientist Elena Sabi, a member of the team that made this discovery, by studying the young metal-poor brown dwarfs newly discovered in NGC 602, we are getting closer to unlocking the secrets of how stars and planets formed in the harsh conditions of the early universe. That's what this is really about. Not just brown dwarfs. Not just the Small Magellanic Cloud. It's about understanding how everything formed, from galaxies to stars to the possibility of life-bearing worlds, under conditions we've never been able to study up close before. And the science checks out. According to Peter Zeidler, another team member and a scientist at the European Space Agency, our results fit very well with the theory that the mass distribution of bodies below the hydrogen burning limit is simply a continuation of the stellar distribution. In other words, brown dwarfs may form in the same way as stars, from collapsing clouds of gas and dust, but they just don't gather enough mass to become fully fledged stars. They're not outliers, they're part of the same continuum. A natural result of how the universe builds its structures. This also supports the idea that substellar mass formation, that is, the formation of objects smaller than stars, has been common across cosmic time, not just in the relatively metal-rich regions we've studied close to home. What we're seeing in NGC 602 could reflect what was happening in distant galaxies billions of years ago, at a time when metals were rare, and yet star formation was still thriving. In addition to providing groundbreaking science, this JWST observation also gave us something just as captivating, a stunning new image of the NGC 602 region, captured in April 2023. The image showcases the star cluster along with its lanes of gas and dust, revealing a chaotic, beautiful environment where stars are actively forming. It's a scene of cosmic violence and creation frozen in time, but blazing with insight. Team member Antonella Nota, executive director of the International Space Science Institute and former JWST project scientist for the ESA, summarized the importance of the discovery perfectly. This discovery highlights the power of using both Hubble and the JWST to study young stellar clusters. Hubble showed that NGC 602 harbors very young low-mass stars, but only with the JWST can we finally see the extent and the significance of the substellar mass formation in this cluster. Hubble and the JWST are an amazingly powerful telescope duo. It's true. Hubble laid the groundwork by identifying regions of interest like NGC 602. But it took the unprecedented infrared capabilities of JWST to reveal the full story. Together, they are transforming our understanding of how stars, and maybe even planets, form under some of the most difficult conditions imaginable. And this level of detail? It would be impossible to achieve from the ground. As Zeidler concluded, only with the incredible sensitivity and spatial resolution in the correct wavelength regime is it possible to detect these objects at such great distances. This has never been possible before and also will remain impossible from the ground for the foreseeable future. So, where do we go from here? Future observations will aim to confirm the brown dwarf's existence and study their properties in greater detail. If verified, this won't just be a one-off detection, it could lead to an entirely new chapter in our exploration of substellar objects across the universe. With every new observation, the James Webb Space Telescope is proving itself not only as a marvel of engineering, but as a time machine, showing us what the universe looked like at the dawn of time and revealing how familiar structures like stars and planets came to be in the most unfamiliar of environments. And now, thanks to this latest discovery, we know that even failed stars can help illuminate the universe's most profound secrets. If you enjoyed that journey through the Small Magellanic Cloud, make sure to like, subscribe, and share this video with fellow stargazers. From failed stars to galactic giants, Spaceverse will keep exploring the mysteries of the cosmos, one discovery at a time. Until next time, keep looking up.